Good morning, class. Development of surfaces, also called pattern development or sheet metal development, is the process of unrolling, the surface of a 3D solid into a flat 2D shape, pattern. If you cut open and flatten a cardboard box, you produce the development of a rectangular prism. This skill is essential in sheet metal fabrication, packaging design, ducting, and pipe fitting. Nigerian manufacturers of ventilation ducts, packaging boxes, cooking pots, and tin containers all use surface developments to cut flat sheet metal or cardboard into shapes that fold into the finished 3D product. WAEC Technical Drawing tests development of prisms, pyramids, boxes, and cylinders. A right prism, a solid with flat, parallel top and bottom faces, bases, and vertical rectangular side faces. Development of a rectangular prism, box. A box with dimensions L times W times H, length times width times height. Step 1. The development consists of 4 side faces plus top base plus bottom base. Step 2. Lay the 4 side faces flat in sequence. Face 1, front L times H rectangle. Face 2, right side W times H rectangle. Face 3, back L times H rectangle. Face 4, left side W times H rectangle. Total strip width equals 2, L plus W, equals perimeter of base. Height equals H. Step 3, attach the top and bottom bases to appropriate side faces. Step 4, add seam allowances if needed for joining, for sheet metal work. Development of a right triangular prism. A prism with equilateral triangle base of side S, height H. 3 rectangular side faces, each S times H. 2 triangular base faces. Lay the 3 rectangles flat in a row, total width equals 3s. Attach the triangular bases to appropriate positions. Development of a right hexagonal prism. 6 rectangular side faces, each S times H, where S equals side of hexagon. Total strip equals SIXS wide, H tall. Plus 2 hexagonal base faces. Nigerian application. A funnel used in Nigerian markets for filling sacks with grain is a frustum of a cone with the top cut off. Its sheet metal pattern is a sector annulus, a donut slice, calculated using the same cone development principles. WAEC Technical Drawing questions on surface development. Question 1. What is the development of a surface and what is its practical use? Answer. Development of a surface, pattern development, is the process of unfolding the outer surface of a 3D solid into a flat 2D shape. It is used in sheet metal fabrication, packaging, and ducting to determine the flat pattern that, when cut out and folded or rolled, produces the required 3D shape. Applications include manufacturing tin cans, ventilation ducts, cardboard boxes, funnels, and pipe fittings. Question 2. A rectangular box has dimensions 80 mm times 50 mm times 40 mm. Calculate the total width of the 4 side faces when laid flat for the development. Answer. Total width equals perimeter of the rectangular base equals 2 times open parenthesis 80 plus 50 close parenthesis is equal to 2 times 130 equals 260 mm. The 4 side faces form a strip 260 mm wide and 40 mm tall. Question 3. A cylinder has diameter 60 mm and height 90 mm. What are the dimensions of the rectangle in its development? Answer. Width of rectangle equals circumference of circular base equals pi times d equals pi times 60 equals 60 pi is almost equal to 188.5 mm. Height equal 90 mm, same as cylinder height. The development rectangle is approximately 188.5 mm times 90 mm. Question 4. Describe the shape of the lateral surface development of a right cone. Answer. The lateral surface development of a right cone is a sector of a circle. The radius of the sector equals the slant height, L, of the cone. The arc length of the sector equals the circumference of the base circle, 2 pi r. The angle of the sector is theta equals r/L times 360 degrees. This sector, when rolled up, forms the lateral surface of the cone. Question 5. A right cone has base radius 40 mm and slant height 100 mm. Calculate A. The sector angle for the development. B. The height of the cone. Answer A. Theta equals A/L times 360 degrees equals 40/100 times 360 degrees equals 0.4 by 360 degrees equals 144 degrees. B. H equals square root L superscript 2 minus R superscript 2 equals square root 100 superscript 2 minus 40 superscript 2 equals square root 10,000 minus 1600 equals square root 8400 is almost equal to 91.6 millimeters. Surface development is where technical drawing meets manufacturing. In Nigeria's growing sheet metal fabrication industry, every air conditioning duct in a Lagos office building, every water tank on a rural household roof, every metal food container, all are manufactured using developed flat patterns that are cut, bent, and welded into shape. This skill translates directly into productive work on the factory floor. Powered by Lightech Academy academy.lightech.com.ng NERDC-approved SS1 Technical Drawing.